Okay, so we are going to start right with 5.2 notes again, which are going to refer to your special right triangles, unit circle, and basic review of solving trig functions. The first thing I need to make you aware of is your calculators, and especially if you borrow mine, you need to now hit mode and make sure that it is in degrees and not radians. So take a moment and check your calculator that it is in degrees and not radians. Okay. So once you have done that, we're going to get started. Okay, so I'm going to start right with your heading here. So I'm going to call this section 5.2. Again, all your foundational trig concepts. All right, so I am going to call this circular functions. So sine, cosine, tangent. We're going to do your reciprocals as well today. And I bet those are not quite as familiar because you don't use them a ton. Then I'm going to say trig functions of special angles. So trig functions of special angles. And my algebra 2 guys are actually also doing those right now, so you will see them all listed on the side whiteboard. The trig functions of special angles. So unit circle and your special right triangles as well. Okay, so I'm going to start with just a basic SOHCAHTOA. So we are going to do sine equal to opposite over hypotenuse. And then your next trig function we've done in the past, so we're going to go cosine is equal to adjacent over hypotenuse. And then next we'll do tangent. And tangent is equivalent to opposite over adjacent. I have no doubt you remember those. Do you remember the reciprocal functions? Let's see. So sine has a reciprocal function that pairs with it. And the reciprocal of sine is cosecant. And all I do to do the ratio for cosecant is I flip it over. So instead of opposite over hypotenuse, it becomes hypotenuse over opposite. Okay, so this next row right here, these are all what we refer to as reciprocal trig functions. These are reciprocal trig functions. Okay. Next, cosine has a reciprocal function, and it is called secant. And secant is going to be found by doing the hypotenuse over the adjacent side of the set. And this one is the easiest. Does anyone remember the one that goes with tangent? Cotangent. Good. So this is cotangent. And cotangent would be the ratio adjacent over opposite. Okay, so the reciprocal trig functions, you're going to take them and you're going to just flip those right over. So with that being said, your first question is going to be to find all 6 trig functions. So this is just like number 11 off your worksheet. So I will call this number 1 though. And your task is we are going to find all 6 trig functions. So same ones that got listed above. And you're going to want to sketch a picture here. And your angle is in standard position, so it's going to refer to your reference triangle. And what I want to do is radical 2, radical 2. So I'm going to go radical 2, radical 2. Okay, so we're going to use that ordered pair. So the first thing you want to do is draw a picture and figure out which quadrant that triangle is going to be in. So I have a positive x value and a positive y value, so that's going to place me where? Quadrant 1. Good. So I'm going to be a quadrant 1, angle in standard position. So I went over radical 2. I went up radical 2. And your point of reference theta is always right in here at the origin. Okay. We also find out 6 trig functions. So do you think we're going to need a hypotenuse at some point? Definitely. So to find the hypotenuse, I'm going to do a trig a squared plus b squared equals c squared. So over on the side here, it's entirely up to you how much work you want to show. If you can just do that in your calculator, that's absolutely acceptable as well. So radical 2 squared plus radical 2 squared equals c squared. All right, so those cancel. I have 2 plus 2 equal to c squared. So therefore c squared is equal to 4, therefore c is equal to 2. All right, so that gets labeled here. Now you're going to find all of your trig functions, okay? So we're going to write out, and I guess I'm going to start right with sine. So letter A, let's go sine of theta. I'll do all these first, and then cos of theta. And then we're going to find tan of theta. And what's helpful is to put the reciprocals right next to them. So we're going to do cosecant theta. We're going to do secant theta. And lastly, cotan theta. So E of cotan theta. And just remember that anything that results in a radical in the denominator does have to be rationalized. Okay, so let's start. Sine of theta. So sine of theta is equal to opposite over hypotenuse. So this is equal to radical 2 over 2. Nothing more you can do with it. So that's fine. Cosine of theta is adjacent over hypotenuse. What do you guys notice? Same thing? Same thing. So radical 2 over 2. No decimals for these. These have to be written as exact value. Tangent theta is opposite over adjacent, which is going to be radical 2 over radical 2, which is just 1. And then next column. So what I'm going to do is take sine and I'm going to flip it over. So if I flip it over, it becomes 2 divided by radical 2. And am I permitted to leave it like that? No, so I rationalize top and bottom by radical 2 over 2. Radical 2. And I am left with 2 radical 2 over 2. And what results is just radical 2, because the 2's cancel. I apologize, I didn't want to. Secant is going to be the same exact thing. So radical 2. Cotangent, I take it and I flip it over. Guess what? Still 1. Okay. So how do we feel on writing the 6 trig functions? Are those okay? Okay. All right, so next, number 2. We give you one more that's kind of similar to that. But I'm going to give you one of your trig functions instead. Let me give people 1 second that are writing here. So here's going to be your wording for number 2. So I want to say that theta is an angle in standard position. That just means, again, you're going to sketch it just like we did that first one. So theta is an angle in standard position. Standard position, hypotenuse goes right to the origin. Find the 5 remaining trig functions. So find the 5 remaining trig functions. You can abbreviate anything you'd like. And these are all just going to be ratios again. So I am going to give you that sine of theta is equivalent to -4 divided by 5. And that your angle is going to terminate in quadrant 4. Remember, quadrants are always associated with Roman numerals. It is required to draw these pictures. Otherwise, there's no way you're going to get all of these answers. So I have -4/5. And I know I am in quadrant 4. So standard position, quadrant 4. My point of reference theta goes right at the origin like this. And then I'm given here the opposite over hypotenuse. So opposite hypotenuse. The 4 is negative because you want below the x-axis, and the hypotenuse can never be negative. Your reasoning, if you square something, is it ever negative? No. So now I need to find my other side because, again, you're going to need it anyways. This is a commonly occurring right triangle. We call it a Pythagorean triple. Does anyone remember what the other leg is? See? 3. You are welcome to use little tricks like that so that you don't have to show Pythagorean theorem. You forget it, you obviously can't. So we are going to find all of the 5 remaining values here. I'm going to write out sine just so that you have it listed for when we go to flip it. So sine theta is -4/5. And then letter B, I'm going to go right into cos of theta. Cos of theta is adjacent over hypotenuse. So that's 3/5. And then letter C, tangent of theta. Opposite over adjacent. So that would be -4/3. And then once more, you're going to take all of these and flip them. So letter D, the cosecant of theta, is equivalent to -5/4. Followed by secant theta. And secant theta is 5/3. And lastly, cotan theta. And that's -3/4. So -3/4. Okay. How does everyone feel with the first two? Pretty good? I'm hoping that's, again, just a nice review of what you've done in years past. Okay, so we're going to get into special angles now. This is where you want to make sure that you're copying these with accuracy so that you don't ever go back to something that's wrong. So next, I'm going to put up your unit circle. And yes, it's on the sideboard because my algebra 2s are using that right now as well. Unit circle, we're going to be centered at 0, 0, and who remembers the radius? What does the prefix U and I mean? 1. So here's your unit circle. So I start at 0, 0. I go over 1. So this is the ordered pair 1, 0, located at 0 degrees. I go back to the center, and then I go up 1. So this is 0, 1, located at 90 degrees. Next, this is -1, 0, located at 180 degrees. And lastly, down here is 270 degrees. And that is the ordered pair 0, -1. All right, so draw your best circle. And the reason we use unit circle is to find exact value for sine, cos, tan, and the reciprocals. Okay. So what you want to recall is on the unit circle, the x represents cosine, the y represents sine. So what's imperative is that x and y represent cos and sine. Cos theta, sine theta. In addition, when you are asked to find tangent, we have an identity for that as well. Tan theta is always equal to sine divided by cos. Okay, so we are going to list them all out. We're going to start with just sine, cos, and tan. Then we will do the reciprocals. Okay, so this is going to be a big list. So ready? Cross here, I'm going to go sine of 0. I'm going to go sine of 90, sine of 180, sine of 270. Okay, so let's grab all of those first. So what that means for sine is I am going to look at all of the y values going right around my circle. So ready? My y values are 0, 1, 0, -1. Next, we move to cosine. All right, so cosine of 0, cosine of 90, cosine of 180, and cosine of 270. And again, these are all the foundational skills that you need to be able to do all the problems that follow and all the rest of the trig units that we covered. So now I'm going to grab all the x values. So x values are 1, 0, negative 1, 0. Last column is tangent. Tangent is sine divided by cos. So next I am going to do tangent. So I am going to do tan of 0, tan of 90, tan of 180, and tan of 270. And there is something a little bit different that occurs with tangent that sine and cosine didn't exhibit. Okay, so tan of 0 is sine divided by cos. So ready? 0 divided by 1 is good. Next, 1 divided by 0 is undefined. We can't do tan of 90. Tan of 180 is going to be 0 divided by negative 1, which is 0. And then what do you see about tan of 270? Also undefined. So 2 places. All right, next we're going to do the reciprocals on these. So let's do cosecant 0, cosecant 90, cosecant 180, and cosecant 270. You're going to flip sine over, okay? So what's helpful is to rewrite it as a fraction first so that you can flip it. So 0 is technically 0 over 1, correct? Okay. So what happens if we take 0 over 1 and flip it? What do we get? 1 over 0, which is undefined. Next one, 90. 1 over 1, if we flip it, what happens? It's just 1. Next one is going to be undefined. And then next is going to be negative 1. Yep. So we'll write out the next couple, or it's kind of up to you guys. If you understand that concept, we don't need to write out the other 2 columns. Is that okay? All right, so all you do conceptually is you take the column, you flip it over. Yes, you are going to find some places where you are undefined. Okay, so the same thing would work for secant and cotangent. So then we get into your special right triangles. Again, I'm sure you are going to remember these from years past. So special right triangles. Looking for somebody. Hello? No, I'm sorry. Sorry, wandering over. Okay, thank you. All right, so next, special right triangles. You have 2 choices with these. You can draw the triangle every time you need those values and do SOHCAHTOA, or you could just memorize these now. For you guys, because we do so much training, I'm going to prefer that you just memorize these lines, but you know, it just all depends on you and how much work you want to add to your plate. So special right triangles are 30, 60, 90. Across from 30 is 1. Hypotenuse is 2. Across from 60 is radical 3. From that first triangle, I can obtain the sine of 30 is equal to 1/2. The cos of 30 is equal to radical 3 over 2. And the tangent of 30 is equal to Opposite over adjacent, 1 over radical 3 rationalizes into radical 3 over 3. Now I do the next angle. So the sine of 60 is equal to radical 3 over 2, followed by the cos of 60, which is equal to 1/2. There's a pattern. You guys see it? Big flip. So I always write them out in that order because it helps. And then tangent of 60 is radical 3. Again, you have a lot of information today. Just make sure, please, that you're copying those correct, just because it creates problems down the road if you don't have them written out. The next triangle we have is the 45, 45, 90. So that is your isosceles right triangle. I'm going to place that one up here. So if you want to draw the triangles and do SOHCAHTOA, that's fine, but I'm just giving you a heads up that we use these a lot. And it's much faster to just have them in the back of your head. So across from 45s are 1s, and the hypotenuse is the square root of 2. So from that, we obtain that the sine of 45 is 1 over radical 2, which rationalizes to radical 2 over 2. The cosine of 45 is equivalent to radical 2 over 2 as well. And the tangent of 45 is just 1. Tan of 45 is equal to 1. Okay, take a moment, check for accuracy, make sure you're good. And then we're going to do just 3 questions where we solve using these guys. Is that all familiar concept to you? Good. I know it's a lot. Mine are started as well. So number 4, we're going to find exact value. And exact value means no decimal answers. These have to be written as radicals. Okay, anyone need those now? Okay. So number 4, I would like you to find exact value. So find exact value. You do have a quiz that falls Thursday of this week, so please start memorizing those angles or be prepared to draw them. So letter A, I want us to find the tangent of 120 degrees. So here's what you do. 120 degrees is not an angle we just listed. So it's not on the sideboard anymore. So what you have to do is sketch this and find what we call a reference angle. So 120 degrees is going to rotate counterclockwise into quadrant 2. What was the rule from yesterday? What did we do? 180, yep, minus 120, which is equivalent to the tan of 60 degrees. Now we know the tangent of 60 degrees, so in a moment you can plug that in. Before you do that, you want to recall that in quadrant 1, all your trig functions are positive. In quadrant 2, just sine. And for us, the reciprocal that pairs with them as well. So T is for tangent and cotangent, and then C is for cos and secant. So in this quadrant, tangent is negative. Now you can flip back to your notes for right now, and the tangent of 60 is equivalent to radical 3. Okay, so that's how you do exact values. Let's do another. Do a reciprocal. I want to go secant of 210. Would you guys agree 210? We don't know that either. So you're going to plot it. 210 is a positive angle, rotating counterclockwise into quadrant 3. My rule, I just flip it, and I'm going to go 210 minus 180. And now you are working with secant of 30, which is absolutely an angle we can find. Before I do that, I recall that all trig functions are positive in the first. Sine and cosecant, tan and cotan, and then cos and secant. secant is going to pair up with cosine, so therefore it is negative. So here's what's helpful to do with those reciprocals. Secant goes with cos. So cosine of 30, you have written down is radical 3 over 2. So now what I do is take it and flip it. So this is negative 2 over square root of 3. I rationalize, and there is my final answer. So I am left with negative 2 radical 3 over 3. Again, exact value indicates no decimal answers. Okay. How are those first two? Okay. All right. So your last two are to solve a right triangle and one little word problem with angle of elevation. So number 5, just 2 more of these. So I'm going to say given right triangle. And we're going to go given right triangle ABC. And B is going to be equal to your 90-degree angle. And I'm going to say A is equal to 41 degrees. And little b is equal to 7.44. We want to solve the triangle. So that means find the remaining sides and angles. So solve the triangle. Okay. Just to cover our bases here. In a triangle, the capital letters are going to refer to your vertices. The lowercase letters are going to refer to your side lengths. So I have a right triangle ABC, in which C is going to be my right angle. It doesn't matter where you put the other two. Capital letters. And I know A is going to be 41 degrees. So that goes right there. And I also know that little b is 7.44. So little b is across from angle B. So I go across, and this is 7.44. And that is little b. Okay. So your task is to solve the right triangle. What's probably the easiest thing to start with? Angle B, I agree. So angle B is equivalent to 180 minus 90 minus 41, which is equal to 49 degrees. Now that you have that, you can add that information. This is 49. And now we need to find the 2 remaining sides. No, it doesn't matter the order that you complete these. So say I want to find little a. So if I would like to find little a, I know that I have a 41-degree angle. That represents my opposite side, and that represents my adjacent side. So to find little a, what I can do here is write a tangent function. And I would go tangent of 41 degrees is equal to little a over my side line of 7.44. I cross multiply and just use the calculator. And that's why I told you want to make sure you're in degree mode for this. So I have 7.44 side length multiplied by the tangent of angle 41, and then enter. Does someone have that yet? 6.47, thank you. So 6.47 is equivalent to little a, because side lengths are going to be your lowercase letters. So this is 6.47. Now you can go about finding your hypotenuse 2 different ways. You can do another trig function if you'd like, or what else could you do? Pythagorean theorem. Yeah, it doesn't matter. If you're not confident your answer is correct, don't use it and do another trig function. But if you are, you can certainly do Pythagorean theorem. So my last one here is to find little c. And to find little c, we'll just do Pythagorean theorem quick. So 7.44 squared plus 6.47 squared is equal to c squared. I know you can do that calculator work. That comes back as 9.86. Remember that your hypotenuse must be the largest side of your right triangle. Okay, and then your side. All right, last but not least, number 6. Not a hard question. All right, so number 6 is a word problem. I'm going to say the Washington Monument is 169 point. I'm going to abbreviate this. I'm going to say monument. Oh, I'm sorry, that needs to be an N. I'll copy that. Monument is, we're going to go 169.29 meters tall and casts a shadow. So casts a shadow. (201.2 meters long. Find the angle of elevation. It's going to take you longer to write the problem than to actually do it. So find the angle of elevation. So you're going to sketch a right triangle to represent this scenario. And your monument you were given is 169.29 meters tall, casting a shadow of 201.2, and your angle of elevation is going to be right here. Okay. So all you have to do is identify which trig function makes use of the opposite and the adjacent sides that you were given. So what trig function here? Tangent, good. So I'm going to do tan. X equals opposite over adjacent. Now I want to make sure we covered this because what do you need to do differently in your calculator when the angle is unknown? You have to hit something. You guys remember? Second tangent. So in your calculator, you're going to hit second tangent of 169.29 divided by 201.2, or a final answer of approximately 40 degrees. Okay, so anytime that angle is unknown. All right, I gave you a ton of information today. Again, none of that should be new to you. It should all be reviewed. Your homework is that second worksheet, and it is just problems 11A and C, 12B, 15B, D, and F, and then 17B and C. Do you guys see where those are listed? Or you can take that sheet out right now and you could certainly circle those. Tomorrow we move into law of signs and area. And then your first quiz for this chapter does fall on Thursday. And it's going to cover days 1 and 2. So what we did today and what we did yesterday as well. So definitely start working on memorizing those angles or being able to sketch all of that out. And then all the formulas that we've completed as well. So again, homework is worksheet 2. Just those select questions. Don't try to fit them on the sheet. There is no way that's going to happen. Okay. And anything you have questions and concerns on, we can definitely address tomorrow.